Now we have the last speaker of this morning, Dr. John Gavloski. Dr. John is an entomologist with Manitoba Agriculture, based out of Corman, and conducts monitoring programs for some of the more common insect pests of crops and provides information on insects, both beneficial and potential pests, to farmers, agronomists, and those working in agriculture. John has a bachelor's degree in environmental biology and MSc in entomology from the University of Guelph and completed his PhD in the Department of Entomology at the University of Manitoba. Aside from entomology, John also enjoys cycling and observing almost any type of wildlife. So please welcome John Gavloski.
Okay, thanks. Okay, perfect. Okay, great. So I've posed a few questions in my title slide here. Often within a growing season, I'll get people calling, kind of speculating, what's weather going to do with our grasshopper population? Or what's the risk of flea beetles going to be like this year? To some degree, we can predict what's going to happen based on the weather. The weather often throws us curveballs, but what I'm going to do today is go over both within season weather patterns, trends, things such as rain, humidity, temperature, wind, and we'll have a look at how those factors affect the populations of some of our crop-feeding insects. At the end of my presentation, we're going to look more long-term, and we're going to look at how changing climate patterns, changing temperatures have more of a long-term impact on our insect populations. And as we go through, I'm going to be focusing on some of the common insects that we deal with in our field crops in Manitoba. So these are the insects that I'll be using as examples. One that I'll spend a bit of time on is grasshoppers. I often have people wondering, we always hear that hot, dry weather favors grasshoppers. Well, why is that? So I'm going to give you 5 ways that hot, dry weather can favor grasshoppers and lead to a buildup of their populations over time. But before I get to the insects, some weather data. And this is from last year. So you'll probably remember last year we had a really cold and wet spring, May and June. So if we look at the average temperatures in Agro Manitoba, so each of these bars is a different region. So you can pick out your region that you're in from the key here. But you can see that in April, we were above average in temperature. Pretty much most of Manitoba was below average in May and quite below average in June as the crops are starting to come up. So we had some cool temperatures. Then when we got into July and the rest of the summer, we were above average for temperature. So cool start, and then things picked up with temperature. With precipitation, it's almost the inverse, aside from maybe April. April was wetter than normal and hotter than normal. But then we get into May and June, lots of precipitation. So remember, May and June were the 2 cooler months, but they also had a lot of rain. And that can have an impact on insect populations. And then it got dry for the rest of the summer. And once again, that can affect some insects. So we're going to try to put the pieces together and figure out how did this in-season temperature patterns affect the insects that we had. And I'm going to start with flea beetles. Just a bit of a background on flea beetles. I'm going to focus in on these 2 species here, the striped flea beetle and the crucifer flea beetle on canola. We've got roughly 86 species of flea beetles in Manitoba. Not all of them are pest species. In fact, we've even got some beneficial flea beetles such as the ones that eat leafy spurge only. But we have about 10 species that will feed on canola, and these two can be serious problems, the striped and the crucifer flea beetle. Now, the biggest risk for canola and canola growers is the length of time that your canola spends in that vulnerable seedling stage. And that starts the day you seed. If your plants can get to the 3 to 4 leaf stage in about 3 to 4 weeks, your seed treatment should be enough to protect you from flea beetles. But anything that holds the plants in those vulnerable stages longer than about 3 to 4 weeks will increase your risk of flea beetles being a problem and you needing to do foliar sprays. So you want to get that early season growth. What happened last year? People got their canola seeded, and then we got all that wet, cool weather through May and June, and you had plants sitting in the cotyledon stage and the 1 and 2 leaf stage for very prolonged periods of time. The seed treatments ran out, and people were having to do foliar spraying. We've had worse years than last year. We've had, 2 years ago, it was the exact opposite. We had some very dry weather, and the canola wasn't growing, and it sat in the very vulnerable stages for a long period of time. Last year, it was cool, wet weather, particularly the cool weather, that kept it in the vulnerable stages. And then what does happen is, once you all of a sudden then do get some days that are nice and warm and calm and great flea beetle feeding conditions, they haven't been feeding or at least haven't been feeding rapidly in a while. The plants are still in the seedling stages. That's when you get a lot of damage. Once the temperature gets into the 20s, if it's a calm day, that's when they'll be feeding very aggressively. And that's what happened last year. The canola was being held back. It was cool. It was wet. Then we got a few days that were ideal and lots of flea beetle feeding and damage. So that's how weather will affect flea beetles. We're going to switch gears and look at heavy rains and how they impact insects. And I've got 3 examples I'll use here: diamondback moth, aphids, and grasshoppers. I'm going to start with the aphids because they're an insect group that is very heavily impacted by both rain and moisture. So the example I'm going to use here is the oat birdcherry aphid in small grains. But again, just to give some background on aphids, we've got, there's been 847 aphid species recorded in Canada. So there's a lot of aphids out there, and pretty much any crop plant will have minimum 1, probably more than 1 species of aphids that feeds on it. So this affects pretty much all your crops to some degree. Not that they're all pests. In fact, there's even beneficial aphids, believe it or not, because ecologically they have their role, and parasites and beneficial insects feed on the honeydew that they produce. But some insects will build up on the crops and compete for the phloem sap and can reduce your yields, such as the oat birdcherry aphid. And this one here can also spread a disease called barley yellow dwarf virus. So double whammy when you have oat birdcherry aphid. Now, aphids are very small, delicate insects. Sometimes they're very exposed on the stems and leaves, such as this species. Other times they might be hidden underneath the leaves, or if it's a plant with hairy leaves, they might be kind of trapped in among the hairs. And where they are on the plant will, of course, affect the impact of rain. But we've seen in the cereal crops situations where after a very heavy, intense rainfall, aphid levels crash. And so that's not uncommon. So as a scouting tip for any farmers and agronomists who are monitoring aphid populations throughout the season, if you get a heavy rain, and I'm talking not just a light drizzle, but an intense rain, a pounding rain on the plants, even if it's a short pounding rain, your aphid levels can take a real hit. So reassess your crops after a heavy pounding rain, especially if you've been noticing aphid populations building. Even again, it doesn't matter so much how much rain we get, it matters the intensity. So a light drizzle that lasts all day, it might have some implications later on because of the humidity it builds up, but as far as that quick reduction in aphid numbers, it's the intensity that really matters. So that heavy pounding rain, even if it's just for, say, 10, 15 minutes, a heavy downpour, that could knock your aphid levels back. So just something to be cognizant of as you're doing your aphid scouting. So I mentioned humidity. That's the other thing. If you get some repeated rain, say you had a week or two of just a lot of drizzle, that can have a different effect. There's a group of pathogenic fungi. There's actually a genus called Entomophaga. Entomo meaning insect, phaga meaning feeding. So these are fungi that feed on insects specifically. And there are species in this group of fungi that attack just aphids, others that attack just grasshoppers, some attack just flies. They're very targeted. So I've given two examples here. Often when you're crop scouting, you'll see these dead flies at the top of the plants. And if you look carefully, sometimes you can see white stuff that seems to be growing out of the back of some of these flies. If you see that, they're infected with the fungal pathogen, Entomophaga, and so flies like root maggots, their populations can take a hit, and aphids as well. So this doesn't look much like an aphid. This looks like a kind of almost a silky mass on the plant. When the aphids get this Entomophaga pathogen, again, it starts growing out of their body to the point where eventually it covers the aphid. And it almost looks like a silky or it looks like it's just covered in a woolly or silky coating. So if you have aphid colonies and you're seeing these silky patches in among the colonies, you've got the pathogen starting to take effect within the colony. So again, that can help influence your scouting activities as well. Now, there's other things that can make aphids change their color and texture and size, so don't get confused. This is a talk on weather, but I just wanted to throw this in since we were talking about aphids with the pathogen. If you see swollen, hardened aphid corpses, that's a parasite, a parasitoid, not the fungus. So the parasitoid leaves bloated, inflated, hardened aphid corpses behind. So what's happened here is you've got a parasitic wasp belonging to this aphidius group. They are good at finding aphids. They whip their abdomen around. It just takes a fraction of a second. They lay an egg into an aphid. When the wasp larva starts developing inside the aphid will die, but it bloats and it becomes a nice home for that wasp larva. And eventually the larva develops, the adults emerge, you get this casing with a hole in it. So again, just don't confuse them with the diseased aphids. Sometimes when you're scouting aphids, you will see both. You'll see parasitized aphids, you'll see diseased aphids. It's good stuff just to consider when you're trying to make your spray decisions, especially because in some of our crops, like cereals, we've got very few active ingredients, and the spray decisions get to be very tough once you get near that threshold later in the season. So good to factor in some of the beneficial insects. Diamondback moths. So diamondback moths are very small green caterpillars that feed on cruciferous plants. Things like canola, cabbage, broccoli. They're cruciferous specialists. They're very small caterpillars, and they are quite vulnerable to heavy pounding rains. So just like the aphids, if you have a heavy pounding rain, particularly on a younger canola crop, they can get knocked off the plants where they'll either be drowned on the soil, or there's always things like ground beetles and rove beetles running around on the soil. They're looking for things to feed on, and a diamondback moth larva is a really good meal for ground beetles. So the rain may beat them on the ground and make them a lot more vulnerable to predators. Also, the humid conditions, diamondback moth, they can also get their pathogens because of the humidity. And the third way that diamondback moth can be impacted by the weather, they're an insect that doesn't overwinter here. Well, at least not well. They get blown in, and when they arrive, If you get relatively mild, calm evenings, it gives them the chance to mate and lay their maximum number of eggs. But we get years, like last year, where they get blown in, they arrive, and we really don't see much in the way of the larvae. I'm going to show you some data here from last year. So annually we put up these pheromone-baited traps for diamondback moth, and we try to predict what the levels are like, where have they arrived in big numbers. Then we could give the heads up to growers that your region seems to have a lot of diamondback moth that have blown in. And we usually have about 80 or 90 of these traps up across the province. So this is our data from last year over about a 6 to 8 week period in May and June. And you can see that in the northwest, in the southwest, our counts weren't high at all. We were just getting a few per week on average and not much of a risk. But if you drew a line from about Portage la Prairie downwards, everything east of that had higher numbers, especially once we got into the area kind of east of Carmen, in Fanistel, Elm Creek, but particularly the the eastern part of the province had some pretty high numbers. And we were warning canola growers, keep an eye on this. The adult numbers are there that should they get good egg laying conditions and should the parasitism and predation be low, you could have issues. We didn't have issues. I'm not aware of anybody spraying for diamondback moth last year. You can see this bar graph here shows when they arrived. It was June, early June, the first and second week in June was when we had our big influx of diamondback moth. So these bars here are showing in that eastern part of the province the numbers compared to earlier on. So what was happening was, I think the diamondbacks that did arrive probably moved in on some of the weather systems that brought some of the heavy rains. The moths got dumped, but we had a period of quite a few days where it was just cold, it was wet, not great conditions for moths to be active in the evening, mating and laying eggs. So even though we did have a lot of diamondback moths get blown in to the eastern part of the province, no issues. So thank the weather for that one. I know it interferes with your seeding and your herbicide spraying and stuff, but it can have its benefits. Another one that we didn't have much of last year was spider mites. Some years we do get them in big numbers. They're not an insect, they're a mite. They thrive under hot, dry conditions. So every now and then they build up to economic populations. And weather is a driving factor. Now, spider mites, if they're on a soybean plant, soybeans have hairy leaves, and the mites actually make this silky webbing on the leaves, and they're underneath, so they can take a little bit of a pounding from the rain, but a very intense storm can knock them off. But probably more importantly, there are fungal pathogens that are very effective at reducing spider mite levels, and when we get these more humid summers, we just don't see the spider mites. So it's almost predictable the years that we're going to see the spider mites. If we've had a very hot, dry summer, I usually expect that by late July, early August, I'll start getting calls on spider mites. Very heavily regulated by weather patterns. Okay, now to grasshoppers. I promised I would go over 5 ways that weather affects grasshoppers and the reasons why grasshoppers are a lot worse after a period of hot, dry years. So we'll start with the very youngest stages of the grasshoppers. So this photo here is of a grasshopper egg cluster. So grasshopper eggs individually look like grains of brown rice, and they're usually in a cluster of about 20 or 30 eggs. So you have this, it looks like a little cluster of brown rice grains in the soil. And one of the questions I often get in the spring, when the snow melt is happening and we're getting some rains, is the ditches are full of water. Should that not drown the grasshopper eggs and wipe out the population for this year? Short answer is no. Grasshopper eggs are coated in a waterproof coating. We call it a chorion. It's a coating where it will allow enough oxygen in for the egg to survive, but it's like a Gore-Tex coat. The eggs will be good. A colleague of mine who does grasshopper research, he took batches of grasshopper eggs one year and put them in glasses of water, left them for a week, dumped the water out, the eggs still hatched. So early season rainfall, when they're the egg stage, won't have a big impact. What will have a big impact is if you get a lot of heavy rains when those eggs are just starting to hatch. And that's what I think happened last year. So when a grasshopper hatches out, now this grasshopper here is already in its middle stages, but when they first hatch out, they're about the size of a wheat kernel. They're really tiny, and they don't have any fat reserves built up. And they have to feed right away to get those fat reserves built up. Otherwise, they're very vulnerable. And so if you get several days of rain right after they've hatched and they can't feed, they're either going to die from starvation or exposure or disease, or there's several different things. But heavy rains in early June for grasshoppers are not a good thing. Not a good thing when you're trying to seed either. But the heavy rains in early June can reduce your grasshopper populations. So that's one way. Number two, summit disease. We're back to the humidity thing, where if you get a prolonged period of humid weather, you could see a decrease in grasshopper levels. So the way this works is a fungal pathogen, in this case Entomophaga grilli. Once again, Entomophaga means insect eating, and grilli refers to the group that grasshoppers belong to, your Orthoptera, which is your grasshoppers and crickets. So these particular pathogens attack just grasshoppers, and in fact some of them are specific to the species of grasshopper. There are certain strains that will attack only two-striped grasshopper, others where it's just clear-winged grasshoppers, and then other strains that are a bit more broad spectrum. What you will notice as farmers or agronomists, the grasshoppers get sick, they climb the plants, and they will cling to the plants very tightly. What happens is the fungus changes their brain, basically, and makes them do things they normally wouldn't do. And when they're really sick, about to die, they climb the plant, they cling to the top of the plant, they die that way. Eventually, their cuticle will split open, and the fungal spores can get dispersed because they're at the top of the plant now. And when the cuticle splits, the fungal spores can then disperse easier. So a couple years ago, back in 2022, I took this photo here where there were literally clusters of summit disease infected grasshoppers in some of the fields. We had some rain, some appropriately timed rains that led to this. All the brown you can see in this picture here, this is all dead grasshoppers clinging to plants. That's the most I've ever seen of the summit disease infected grasshoppers. It was quite an incredible scene, actually. That can help out in some years. I've been asked before by farmers, can we not breed this fungus and spray our fields with it? The short answer is no, because first of all, you need the damp conditions for the fungus to really be effective. It's a really tough thing to produce in a lab situation. It would probably be very expensive as a pesticide. So it's not something that we can really make into a biopesticide, although there are other fungal pathogens that they can produce that can be effective. It's just they're not on the market right now. That's another side note, maybe something for another year. Third reason that grasshoppers are often reduced in favored in hot, dry years is the cooler summers will slow their rate of growth. So a bit of background on the grasshoppers. We've got about 85 different types of grasshoppers in Manitoba. There's 4 we consider to be pest species, and all 4 of those lay their eggs in the late summer. They overwinter as eggs, and they go through one complete cycle. Anything that slows down their growth will mean less time in the egg-laying stages later on in the summer. In 2023, we had a really, really hot start to the season. I was seeing adult grasshoppers from our pest species by the end of June, which was exceptional. They had a lot of time to lay their eggs that year. Last year, things were delayed a little bit. But I'm going to get into the grasshopper forecasting a bit later. But if you get a year where they're not becoming adults until late July into August, they just don't have as much time to lay their eggs as if they became adults earlier. However, if that first frost doesn't occur until well into October, that may still let them lay their full complement of eggs, which is actually what happened last year. So even though we had less grasshoppers in 2024 than the previous year, they had good egg laying conditions because they had a very extended summer. August and September were very mild and good for them to lay their complement of eggs. So that brings me to the fourth way that hot, dry weather favors the grasshoppers. Most of the eggs will get laid during August and September. And if you get warm weather and fairly dry weather in August and September, that will let the grasshoppers lay their full complement of eggs. That's exactly what happened this year. If you remember back to those weather graphs I showed you at the beginning, September on average was at least 5 degrees warmer in every region in Manitoba. So they had a very good egg-laying conditions this past year, and our first widespread big frost last year was October 3rd. So again, even though we had fewer grasshoppers going into the year, or after the rains in June, the grasshoppers that were present had good opportunity to lay their full complement of eggs. So don't take grasshoppers lightly going into next year. I'm not going to show the grasshopper map in this presentation because of time. Our grasshopper map this year has a lot of green and low risk areas on it, but I caution people, the map is just a map. The forecast is the interpretation around that map. Don't be fooled because the map has a lot of green on it. We still could have some grasshopper issues if we get appropriate conditions for them next year because they had good egg-laying conditions. And the final way that grasshoppers can be of increased risk in a hot, dry year is if we get drought conditions, you have less natural vegetation. And that will make your crops more enticing to grasshoppers. Of our 4 pest species of grasshoppers, they all have other things they will feed on other than crops. One of the pest species, clear-winged grasshopper, feeds on only grasses. The other 3 are very general in their feeding habits, but they will feed on roadside vegetation very readily, and that's often where they're hatching out. Now, if that roadside vegetation just isn't growing in a nice, lush, dense way, your crop is more enticing, and they will move into it at a quicker rate. So sometimes having some nice, lush vegetation outside the field can help keep the grasshoppers from moving into the field. And then there's insects that actually do better, that like the wet weather. There's a group of flies, we call them midge flies. There's actually several families of flies we call midges. But there's one group that includes your wheat midge, your sunflower midge, your swede midge. They're all pest species. They all like rather damper weather. They're very small, delicate insects, and if it's too hot and dry, they can desiccate and get killed easier. So in the case of sunflower midge, so sunflower midge creates sunflower heads that look like this. The larvae feed around the outside of the sunflower, and it creates a hormonal imbalance in the sunflower, and the heads just cup in and become really deformed like this. The fly that lays the eggs around the head, very small, delicate midge fly, and if you get some rain, that will actually stimulate greater emergence of the flies out of the soil. They will usually wait until the evening when it's damper and cooler and then go and start laying their eggs. They like the dampness. They don't do well in very hot, dry weather. So with sunflower midge, our cycles can be somewhat predictable. Again, last year we saw a bit more of it than we have in a few years because we had that cool, damp weather in May and June. It would have been really good weather for them to be out laying their eggs. So they're certainly tied in with the weather patterns quite a bit. And of course our biting flies, things like mosquitoes and some of our biting flies, they need standing water in order to reproduce and breed. So you'll see more of them in wet years as well, and that can be a major problem for livestock as well in some years. I had to have patience taking this photo here because the mosquitoes were on my hand. I'm trying to take multiple photos before they flew away, so they had a really good blood meal as I got the photos of them there. Temperatures and insects. So one of the things that warmer temperatures will do is it will speed up their life cycles, which can be a good or a bad thing depending on the situation. So last year we had armyworm issues in our cereal crops. This is the adult armyworm, and these are the larvae. So I'm not talking about Bertha armyworm here. I'm talking about, we sometimes call it true armyworm or cereal armyworm. Caterpillars that preferentially like grassy plants, but if they destroy a field of wheat or fall rye or something, they will move into broadleaf crops and feed after that. The adults don't overwinter here. They get blown in, kind of like diamondback moth. One of the questions I was getting last year was, how long are we going to have these caterpillars before they move on to their next stage? And that's really highly tied into weather. If the weather stays in the high 20s, it could be just over 2 weeks in the larval stages. Now this research here was done in indoor conditions. They had constant temperatures. When they kept them at 29 degrees, 16 days is what it took. At 21 days, so a little bit cooler, it took them 26 days to go through their larval stages. And at 17 degrees, fairly cool weather, they were in the larval stages for 40 days. Now there's trade-offs here. They're probably not feeding as aggressively in the cooler weather, but they will stay in those larval stages longer, which will possibly make up for the less feeding that they're doing. But their life cycle is very intertwined with the temperature. The other thing it might do is it might push back that first generation, make it so that second generation of armyworms is coming out much later in the summer, meaning that it's irrelevant to the cropping situation. They're probably coming out when you're harvesting your cereals already. So it will affect their life cycle. And same situation with diamondback moth. Now, in this case, though, they have 3 or 4 generations in a year when they come in early in Manitoba. So what it might mean in the case of diamondback moth is they get that 4th generation versus a cooler year, it might just be 3 generations. So with them, their time to complete a generation, it can vary anywhere from about 3 weeks to almost 7 weeks, depending on the weather and food conditions. When they come in early and they have good egg-laying conditions and they have good conditions to go through their cycles quickly, we can easily get 4 generations, which will increase the risk, providing that natural enemies or other weather events aren't taking them down. Sometimes their populations do crash. And also aphids. Aphids go through many generations in a season, so those generations will be happening quicker under the warmer weather. Okay, so I'm going to shift gears now and talk about long-term climate changes in insects. So far we've been focusing on within the season climate patterns in insects. So now we're going to twist gears to long-term changes and what happens when over time average temperatures go up. One of the consequences is some of the insects that overwinter south of us start expanding their ranges closer to our borders. And what that means is we potentially have earlier arrival times. And one of the insects that this has been well documented in is potato leafhopper. So potato leafhopper, they're a very small green insect that has sucking mouth parts. They put their beak into the plants, feed on the phloem sap, and on some plants, that will cause, they kind of plug the phloem vessels, and you get this almost wedge-shaped pattern on the leaves of dead tissue that we call hopper burn. So not good for the plants. So ideally, we don't want them coming in too early because they will go through more generations and build up and become more economical. What they've been finding in some long-term studies is that on average their arrival has advanced by about 10 days over most of the northern U.S. states and even into Canada over the last few decades. And they've come up with an equation here where for every degree increase in temperature, you get roughly 3 days earlier where the potato leafhoppers are arriving. So here's a map. The stippled part here shows the traditional overwintering area of potato leafhopper, and these are the more traditional dates of their first arrival. But again, as you move this northward a bit, which is what's happening, it just means that their arrival is a bit quicker into Manitoba. So we may start seeing some of the insects that overwinter in the south arriving a bit earlier and becoming things we need to adjust our scouting for. Diamondback moth, another one that until recently we've expected didn't really overwinter in the Canadian prairies. We have some anecdotal data that possibly in milder winters we may get some low-level survival here. But for the most part, they overwinter in the southern U.S. They build up there, and they get blown into Manitoba. It's not a purposeful migration. They get blown in. But again, the closer they're overwintering to Manitoba, the earlier we're going to be getting them. And I know there's been some studies that have shown that they could be potentially increasing their overwintering ranges as well. Now, for people who like insects like me, there could be some benefits to having ranges expand. So this work here was done by Richard Westwood at the University of Winnipeg and some local scientists. And what they've been looking at is some long-term studies on the overwintering range of a couple butterflies. One's called the Buckeye. That's this one here with some nice spots on it. And the other one's called the Baltimore, and it's a nice-looking butterfly as well. And what they found in a nutshell is that the range where they're finding them in Manitoba has increased. In the case of the Buckeye, by about 150 kilometers north, and in the case of the Baltimore, by about 70 kilometers north. And aside from their range, we're seeing them longer into the summer. So, in fact, aside from those two butterflies, they had 19 butterflies in their study that they were looking at, and they found that 13 of the 19 butterflies had significantly increased the amount of time that they were being seen in Manitoba. And on average, it was about 31.5 days, so not nearly a full month longer that we're seeing some of these butterflies in Manitoba, which if you're someone who likes watching butterflies, it's a good thing. But the problem is the same principle applies to some of our crop pests as well. So it's giving them more time to feed, to lay eggs, and to potentially go through extra generations for some of the insects. So that's some of the trade-offs with warmer average temperatures overall. And I'm going to finish up with an example that has been in the media quite a bit. It's not an agricultural one, it's actually a forestry one. And this is mountain pine beetle. So mountain pine beetle, small little beetle, it's native to North America. In fact, its range in North America was restricted to a very narrow part of Western Canada. So in Canada, traditionally their range was just in kind of a southwestern part of British Columbia. Recent years, they've really, I'll say the last couple decades, we've seen a major expansion of their range. Now, they're a native insect. They weren't brought in. They've been here all along, but they could not really expand their range outside of that pocket in southern BC. But there was a number of years consecutively where BC did not get the colder winter temperatures that would normally be killing off mountain pine beetle. And they started to spread further and further east and north in BC. Now, wood movement might have assisted this a little bit too, but we're at the point now where they've spread into Alberta, if you go into Banff now, it's not uncommon to see sites like this where you've got dead trees because of mountain pine beetle. And they've even spread, well, into that north central part of Alberta, and there's a population that's established in the Cypress River area of Saskatchewan. So they're expanding, Cypress Hills part of Saskatchewan. There's a population there. Their range is expanding, and there's been a lot of work done on their overwintering biology, which is very highly affected by cold temperatures. Bitterly cold winter temperatures will kill them off. If we get fewer of those, that increases the risk. Now, southern Manitoba, we're still getting the minus 30s and minus 40s for at least brief periods of time over the winter, which should protect us. If that starts changing, then we could be more vulnerable too. But some areas further west have been getting less of those extreme temperatures, which is enabling these to spread. So I'll wrap up with that, Amir, and if there's time for questions, I'd be happy to take any.
Yep. Any question? So if no, please give thank our applause to John Gavloski.